All right, let's get started. So this is video 6. I believe this is the 4th part in this series on Base 62. Base 62 encoding, decoding. And this is about URL shorteners. And what we're basically doing is using a simple example to kind of show different functional programming styles in different programming languages, more or less. So a little bit about, this is the 4th video, and we have an article where you're comparing some basic FP support. There's a follow-up article, is Java a good FP language? And then there's an article by Tom Hicks translating this to Clojure. So basically what I did is I started with a simple Java Base 62 encode decode written in fairly procedural Java, converted that to procedural Scala, made it in my mind a more functional version of Scala and a more idiomatic version of Scala, and then I ported that to Clojure, and that's what this article is about. So we'll talk about that, and then we'll talk a little bit about Tom Hicks's thoughts on that port, which were interesting. So just to kind of show, and then an example of a URL shortener. If I had a really long URL like this, I could shorten it by converting that to a number using hash code with math absolute so that it's positive. And then I get a short handle, which is the generated string. And then I can, again, take that short handle, print it out, or convert it back into a number. So that's sort of the basis of the URL shortener, Base 62 URL shortener. Now what I've done is I've converted this to Clojure. So this is the Clojure version, which we're going to walk through here shortly. I'm going to run it with Leningrad. I don't know how you pronounce Len. I guess Lean. I don't know. Anyway, so you can see that DVT 30 matches that. We have this that matches that. So it's the same program as the Java, as the 2 Scala, but it's written in Clojure. So with that, let's take a look. So again, just like I've done in the previous videos, I've got a comparison. I just created a little page so it's a little easier to A/B these. So this is the Scala version. This is the equivalent Clojure version. This is not my first time using Clojure, but I wouldn't say that it's something that I have a lot of experience with. So this is defining a main method in Clojure. We just do a printf for brevity, and because I don't know Clojure that well, I just used printf, and I call the various methods: convert to long, convert to encoded string. I don't declare a bunch of temporary variables, and again, that's more just to get something working. Clojure is not a native language for me, so to speak. So this is a side-by-side comparison of what I was calling the idiomatic Scala version, which has more functional programming goodness, and the Clojure version. And you could see line by line, it's a kind of like an interlinear, except it's, instead of line by line, it's side by side. So I don't know how to say that, but it's like an interlinear translation. So you have Scala on the left, you have Clojure on the right. Here we're defining bucket value. Here we're defining bucket value. It's power digit 1, power digit 1. You can kind of see the equivalent definitions on this side. There's our placeholder. There's our placeholder being defined. Here's our results. Here's our results. So you can see the Clojure version and the Scala version, and kind of use one to understand the other. If you're familiar with the Scala, looks a lot closer to Java. And then we have the accumulate digits, which gets used by the convert to encoded string. And you can see the if statement here, the equivalent if here in Clojure, the sort of reverse Polish notation that it uses. Everything is a function. or a list of arguments to a function. Okay, so let's take a look a little bit further. I mean, so far, the Clojure's kind of beautiful. I'll admit, it wasn't easy for me to write it all. I haven't done a lot of Lisp programming, but when you look at the results, it's pretty. It's a very small syntax and pretty expressive. My issue with porting it to Clojure was in my opinion, it's very hard to debug compared to pretty much any line. I ported this to TypeScript, JavaScript, Java, well, functional Java, Kotlin, obviously Scala. Oh, what else? Rust, Go, probably a language or two I forgot. And I think the hardest time I had was with Clojure because the tooling, just trying to debug things, was really difficult. But you can see that it's got first-class support for functions. Pretty much everything is a function, so you program with functions. Here's an anonymous function definition in here, which is equivalent to this sort of lambda here. Well, it's not called lambda in Scala, but this anonymous function here in Scala. Then you have this, that would be like a lambda in Java. And then you have the, the do pal, the pal digits base, which it's a recursive method. Do the same thing in Clojure. Syntax is a little harder to get used to because the sort of the reverse notation. And then we have the append save to list in Scala, and then we have the equivalent in Clojure. And this could have been written out with more blocks. It could be all on one line, right? Because it's parentheses, but then it'd be potentially harder to read. So I guess they're fairly equivalent otherwise. If you look at the logic, it's the same. Not equal digit x 0, digit x not equal to 0. I mean, it's just different, but it's doing the same kinds of things. Then you have the convert to long. Convert to long. This uses a reduce operation. And here we use a fold left. So the reduce, I think in most of the languages that I dealt with, it's called reduce or something, or sometimes just fold. But basically this fold left and reduce are doing the same thing. Here you have an anonymous function, and it's doing more or less the same as this. Instead of returning a tuple, you return what's basically a list of values. But you can see it's equivalent to this. So line by line, very close to what you see left and right. And here's compute value. Again, we declare the variables with val in Scala, which means they're immutable. And in Clojure, we use let, which basically defines these variables, which are also immutable. And then you can see here we're multiplying digx times multiplier. Since that's the last statement, that's the return value. Similarly, since this is the last function that's called, which is the multiply function, taking digit and multiplier, that's the return value. So these are functionally equivalent. You'll notice that there's no typing in Clojure. Do that. Here's the full Clojure example if you wanted to compare line by line. And there's the full non-functional Java version, just for reference. So my ideas behind this were, it's a beautiful language. It's very functional. It's very hard to debug. And, I was asking some different people that are using Clojure, and they're like, oh yeah, just use the command line and use the interactive interpreter, and that's how you debug things. Well, yeah, I was doing that. It's still not easy though. Like, you can't just put a breakpoint. I mean, I haven't figured out how. I'm not the best at tooling. In fact, I wrote all this on my laptop. The tooling was working fine, the tooling is, in my opinion, it's the hardest to work with. Of all the languages that I worked with, the tooling for Clojure seemed to be the hardest and the least advanced. I know people aren't going to like that, but that was just my opinion from using it. Was, wow, this is... Tom Hicks wrote this great article, and he had mentioned a little bit about Clojure, and that, he was intrigued by this, but then didn't think translating it was the best, which is kind of what I said too. If you take a Scala program and you just kind of transliterate it, which I found out it's not really the right terminology, because transliteration is really about sound. It's more about more like an interlinear translation, which often use transliterations, but it's more of an interlinear, but it's really not that either, because it's side by side instead of line by line. But it's basically set up in such a way that you can easily compare the languages. Well, his thoughts were that's not the best way to use Clojure, so he rewrote it, and so the way that he defined, basically wrote the same thing and then converted it. There's a link to the full code here. I want to compare it. So I actually know Tom from when I lived in Tucson. We used to go to the Java users group meetings and a few other local meetings together. So this is his version, which probably a much better representation of Clojure, I'm sure. Uses partial. Yeah. So I would definitely check this out and his article. He's obviously worked with Clojure a lot more than I have. But it was fun. It was interesting. I enjoyed messing around with Clojure, enjoyed learning it. Of all the languages that I ported this example to, Clojure was by far the hardest for me. Scala was easy, Kotlin was easy. TypeScript, JavaScript, I didn't have any issues really. Python, pretty straightforward porting. Clojure was the toughest for me. It's probably the language that's the most different than the other ones. The others have a lot of similarities, so I think that's why it was a lot harder. And I think I don't think the tooling for Clojure is good as the rest. That said, it's a very eloquent and beautiful language. It's interesting. I think it's nice to learn just to get a better grasp of functional programming, because in Clojure it is only functional programming, so you have to sort of embrace it. So it was a good learning experience. I highly recommend checking it out for that alone, and maybe you'll enjoy it more than I did when it comes to the tooling. But again, if I was working on a team of Clojure developers and would kind of get the graphs for the flow, it might be different. But it was a good learning experience. I like Clojure. I would definitely mess around with it again. And so I think what we'll cover next week, we'll cover porting this to maybe back into functional Java from functional Scala. I think that's the direction I went. It was functional Scala, then from that to a more functional Java. Then it was Clojure, then from that to more functional Java, and then got into doing it in JavaScript, TypeScript, Python, Rust, and a few other languages. I don't remember the exact order that we did that, but we were just messing around and porting it to various languages and just trying that out, and then comparing the functional programming support. Now, obviously, the functional programming support, in my opinion, in Scala is really excellent. In Clojure, that's just what it is. It is functional programming. There's no real option. It is what it is. So, yeah. So check out that article and check out the earlier videos. And thank you for your time. And tune in next time. We'll cover porting this to a different language, and then cover more of sort of compare the functional programming support in that language to other languages. Thanks again.